Hello, hello, and good morning. How are you all doing today? I think we're all looking good. Just hide all this stuff around so I don't drop water or tea or whatever all over myself. Okay. I think we're good now. So happy Sunday, everyone. I am looking forward to a longer day where we get to work on this ECS project. I've been thinking about it to try to figure out exactly how we could do this. I don't know if I have the right solution in mind, but I think I have a pathway forward. So we can maybe test that, see where we are. So let's say we have something like a situation like this. We want something that has both location and colors. And that means we're going to want entity 3, entity 1, and entity 3. Entity 4. With the other two being ignored. So if I store all of the tape, the bit maps, the bit mass, into a hash map with the type IDs for each of these, that's great. But then I need to know okay, this first one on the right corresponds to locations. This second one corresponds to colors. I'm gonna need to know that. But if I can figure that part, then we're golden. We're good. So my initial idea was, as they come in, I put them into an array. So I have the map array. Which I suppose might look like these things in the order that I'm going to be checking them. So we're going to have U here first. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Then down here, we have that. Then these correspond to, in the order that they're put into this array, correspond to another array of I guess a series of arrays, because each of these locations, colors, we're going to be grabbing them out, right? But we only need to grab it out if we know that it's there. So we're looking for these two things. Let's grab these two things. So locations and colors. So we also going to grab U out and U out. And so you have then there's a vector of these two that sort of just comes along with this, right? And so I know that this corresponds to the locations and this corresponds to the colors, because the order that I put these two things into maybe a temporary vector, a temporary array. Then I think it's going to be, okay, look at locations here. Do you have both of these? If you do, give me, let's see, for the current index okay, so we need our mask too, which I don't have. This is just the map of these. Okay, so we need one more, which is going to be essentially the mask or the map. And then this is where we would have something like In this case, there's only two things. So we would have 1, 1. This would be 0, 1. This would be 0. Oh, this would be 1, 0. Because location's the first. And this is 1, 1. And then we can do, okay, for the first one here. So for the first item in here, we want to get, okay, do you have a location and a color? So we do the bitwise or, I think, or bitwise and. If that's true, then yes, give me reference to this and reference to this, and stuff that into like essentially two vectors. We might end up having multiple loops. I'm gonna do one for one thing first. Maybe that'll help my brain wrap around like what I need to do. So in BBECS, we have our entities here. Let's see. So we're gonna want our bit mask, our bitmap. Right, and so we're gonna want to start with the bit map is this hash map and type ID, right? So I need to be able to store these away. So just to know like, okay, a location is this, a color is this. And so the first one that goes in there is, I think, gonna be 2 to the 2 to the first. Can I do that? No, 2 to the 0th. Okay, so 2 to the 0th will be 1. And then 2 to the first, 2 to the second. So it's going to be based upon length minus 1. Is that true? It might be just length. Okay, so when we register an entity, we're gonna push the bit mask, so that's our map. So I think these should be relabeled. Maybe not. Okay, we put our bit mask in here, so it's a new entity inside. We had an empty cell to all the components. Okay, that's great. Now, if we add a component here, new bit mask. Okay, so if the length is 0, that's going to be 2 to the 0th. So that's perfect. If the length is 1, it's going to be 2. If the length is 0, I want 2 to the 0th, which is right. If there's 1 already in there, I want 2 to the first, which is going to be 2. Yeah, okay, that's going to be correct because it's 1, 0 then. So this is the new bit mask, and then we insert this type ID to the new bit mask. Okay, perfect. Now, we're going to query for one thing. But I don't think we can do a different name with different options for this, can I? because I think I'm gonna have to do like a query. If it's query one thing, I could do a vector of these or an array. It's an unknown size. That might make sense. I don't know if I can do that because the size won't be known at compile time because it's an unknown number. So then we might have to do vector. So I'm going to go ahead and not return anything right this second. What I'm going to do is just ignore that. I want to wait until we see, like, just print these out as we go along. Okay, so we know we're going to create a some kind of like response, we know this T is coming in, so we need to grab the map. We need to grab the map for this type. So let bit map I think that's exactly how it works. Okay, so we get the type ID. Now I want to get the bitmap out. Okay, so we do that. Now there's a possibility that this doesn't exist, right? That we're requesting to get something that won't give us anything at all. So we should we'll have a vec of something in here. I don't know exactly what yet. So I'm going to do, okay, let bitmap value equals if let, and then this is going to be some bitmap value equals this. Okay, so if you find that, return a bitmap value. Otherwise, I want to just do an early return of the result. We didn't find anything. And that's it. Mismatch type is expected U128. Because you're an unknown. Yes, the bitmap is the hash map. So self.bitmap, if we get pass it a reference to the key, which is this type ID, that should give us an option. So we unwrap. Oh, wait, we don't need to unwrap. Yeah, we're handling that here. Okay. Now, if we reach this point, we're going to return the result. Okay. So that'll make this happy. So we should essentially not get anything at all at this moment. Okay. Now we have the bitmap value. The thing, well, okay, so this is just for one. We're potentially gonna have to do this for multiple, right? Because like, what if we're querying for both things? In that case, I don't think I can. I think I'm gonna have to say that you take in the types, which is I'm gonna have to be a vector of basically t. But I don't think that's going to be super easy either. Oh, can I implement something that... Oh, I don't think I'm going to be able to easily impl to like grab everything else out. Okay. Let's say I didn't do the, well, so I want something with both of them, right? So we need to figure out for each of these, loop through, I guess, like look at the bitmap for our entity. So we know at the very least we need to loop through that. So let's like annotate this and like try to figure out how it's gonna work. So we're going to loop through the bit masks. So loop through the bit mask once. Nope, not. Oh, that's cool. If I give it a comment, it's gonna try to actually do the thing for me. I don't want to do right this second. Okay, so we're gonna loop through the bitmask. If the bitmask is set, then add the entity to the result. I mean, yeah, kind of, but we need to, I guess, like if the bitmask is set, is set for the types being queried for. Okay, so loop through all the bitmasks. If the bitmask is set for the types being queried for, then add the entity to the result, which is not necessarily super easy. Now, do I want to create like an entity, an entity struct that then like just sort of temporarily holds references to these components? I don't know if that would be helpful. I don't think it would be. We're just gonna return probably a vector of like the rows. Or we return a tuple corresponding to what we requested in. That could make more sense too. Okay, so if the bitmask is set for the types being queried for, then we want to essentially add references to the components to the result. and then return the result at the very end. So imagine if I just had a tuple of t, just a reference, a mutable reference to t. I don't need this thing here. We're just going to have our t come in, and we're going to give back this. You probably are going to argue that that it doesn't need to be a t. Oh, it needs to be a vector at some point in time. So it does need to be a vector of these components. So give me this component, but only if the entity has a query for all entities with a given component. So in that case, this would be a vector of a mutable reference to t. T being the component that we're passing, that we want back. And we can actually just make this non-mutable to begin with, and we'll have a mute version, maybe. Unless we do interior mutability, then there won't be a mutable version. Okay, so we start building a result and we return that here. Great. We figure out what the type ID of this type is. Okay, great. Then we attempt to get the bitmap value out of our bitmap using our type ID. So this is going to be that like 000010 or 01 or 111. Or I guess it would never overlap. They're always going to be unique for this. And we're also going to need, okay, so then we're going to loop through our bitmask at this point in time. Okay, so we're gonna loop through our bit masks, and Lumicode, hello. How's your Sunday going? We're gonna loop through the bit mask, and then for each one of these, we're gonna use that to compare with the bitmap value. So we only have one bitmap value right now. Good. Got a coffee and a Rust stream, so I'm good. Awesome. Got my tea here, so I'm in a similar. I'm in a similar thing. I've got a Rust stream going on too. How strange. Okay, so since we're doing just one here, then we should be able to just check one thing, right? So if this is going to be our bit mask, we're going to have to dereference this. If that and our bitmap value, so a dereferenced bitmap value. So if that's Ruthie. Wait a second. I now need to remember how this all works. Okay, so we have a location bit mask, we have a size bit mask. Okay, and we're gonna have our like let player map. It's gonna be equal to 0b. Let's say this player has both of them. So it would be like that. What I want to do is debug. And this is going to be the player map and location bit mask. Can't we use bitwise operators for those? Yes, but I always forget what the bitwise operators are. Oh my gosh, I'm not even using you. Don't worry about this. Okay, so that's one because it found one in the same position. For the location bit mask. So now does this give me like a true? No. Okay. So I can't do something like that. I can do this, and this should give me a 2. Yeah, so that gives me a 2. Then what was the other thing? It's just less than. Yeah. Did we? Oh, I didn't save like where those were. And the documentation is not super easy to search for to find where those are, which is unfortunate. Okay, so if I do that, what does that do? That's a 12? So what? 1, 2, 4, 8, 16. So it'd be 8 plus the 4 essentially. Or did it shift everything over by 2? Is that what happened? It shifted everything over by 1. So this is now 1, this is now 1, and then 0, 0. Yeah, I don't want to do shifting. In this case, what I want to do is I want to see, hey, for your player map, do you have a location bit mask? Like, do you have that in there? So these are both sets, therefore it should be a 1, and we should check that. And I think a 1 matches. Okay, so to check this, I think it would be and then I would do if that's equal to the location bit mask. Is false. Okay. Oh, wait. Size. Oh, yeah. Okay. It depends upon where it's where it is too. But let me try. If you can't like where is it? Where's like the domain for it? So I have some whitelist on, and I might be able to whitelist it before you you post it. Okay, so this becomes true, and then we can do and layer map, and this is gonna be size bit mask is equal to size bit mask. So this should be true too. Tutorialspoint.com. I don't think I have that. Hold on. Oh, this is cool. Okay, so if I do that, move. Okay, I whitelisted tutorials point. Bitwise operators. Let's take a look. Right, so if I want to find out if something is in the mask, then I think I just want the and. Or maybe we can use the XOR. Maybe XOR would work for us. Is there X and? So I would want to do a debug location XOR. Oh, but that's not to multiple. Can't do this to multiple things. So if 8 and bit mask equals 8. So, okay, I have a component whose like bit is flipped for the 8 bits. That means I have 1, 2, 4, 8. I have four different component types, right? So I have the fourth component type. Let's say it's size. And so if you have a size, you have your 1 bit flipped for that. And if we do and, I think it's just and, right? Because and will give me the value back. Yeah, it's just gonna be and. So it's what I have here. So then coming out here, okay, so if bitmask and that is equal to the bitmap value. Then we know that this entity is what we want. If you want to check if location bitmask is in player bitmask, you can do location bitmask and player bitmask equals. Yeah, okay. So I think it's going to be similar to this. So we know that you have everything that we're querying for. We're only querying for one thing. So you have it. We are gonna need the index as well. So let's also just enumerate this. And we're gonna get the index and this bitmask. Okay, so if that, then we're gonna want to push in this component value. So then we want to grab, okay, so then probably here. Is, let's see. Let's, our components, okay, so components get type ID, unwrap. It's probably not get the index, like probably close. Okay, components equal to self dot components that get the type ID. Okay, and then we unwrap that once, and that's it. This gives us, okay, a vector of this option box dyn. I probably can start with this loop, I bet. So, okay, we get this, and then we can reach into that and add this to the result. So, result, we're gonna push, and this is gonna be components of index, and then we can just unwrap that. But I need you to be a reference. Oh, right, and you're probably a boxed, so you're a reference to a box. T. Oh, and dyn any. Yeah, okay, so we're gonna move out by accident. Move occurs because that has type option. When I unwrap, oh, because when I'm unwrapping, in order to unwrap, I need to get access to it. if I, let's see, I won't necessarily be able to do like a default value or anything. Oh wait, consider borrowing the options content. Wait, maybe I can do that. Okay, so how about this? That's using that. Okay, so hold on. What do we got here? So your components, okay. Components of index gives us, okay, this option. So if it's a ref, I then want, okay, so I take this option and I want to borrow it. Can I borrow that? I don't feel like that's right. Hold on. Before we do this, let's grab the thing out and we'll do one at a time so that we get the most help. So let component equals, okay, this is gonna be components of index. So I want to do that. Okay, so now we have this option box dine any. So if I do a if I do component dot what, okay, so there's as dref, leave the original option in place, creating a new one with a reference to the original one, additionally coercing the contents via dref. Okay, so that could potentially work. Converts a reference to a function to option T. Okay, that's not what we have. We have ownership. Because like, okay, we have this. So we have a reference there. I kind of don't want to take ownership of this option. I think that's our problem. Yeah, I can't move this out. I think instead of this like index, unless there's something where I can like yeah, that's not gonna really help. Okay, I can do get. Returns a reference to the element or subsize depending on the type of index. Okay, so if I do a get with this index here, that gives us an options. Then we're gonna unwrap you. Okay, now we have this option there like that. Then I think we can now do a as ref, which converts that to an option with this box dine any. So then we can unwrap it again, and now we have this box. Okay. Okay, now we have a box dine any. Okay, it's a reference to the box dine any, but we can then throw that into our array. So we can do result dot push component. And then we can return this. We haven't run this. We haven't run this yet. I could do, you know, I should get really fast at doing these. That'd be pretty awesome if I can do here prediction. Oh, that was a previous question. Will this code work? Prediction started. Will this code work? I have to believe, but now you all can believe too. Okay, so now I need to write the test to actually use this. Are you putting all of your channel points into this? It's a lot of channel points to put onto yes. You believe, okay. All right, so test querying for entities. So we put 3 entities into here. You have size and location. You have size and location, and you have only size. I don't think I need this like for loop in here, do I? That's just like checking to see if they have the thing. I don't think I need that. We're just registering these components, these entities. Okay. So now, okay, we can debug the entities, which we won't actually see them unless I figure out what the thing to add in there is. Okay, how do I verify this? I need to now do the query. So we're gonna do let query equals entities dot query, and then we're gonna pass in. Okay, so entities dot query with the type of, let's look for everything that has a location. I just want the location back. So no location. That's it. Okay. We're gonna get this vec. Okay, so then I want to let's our length for this should be 2. Okay, so query length should be 2, and let's also assert equal like the first one and the second one, right? So query 0 just query 0 is going to give us a box dine any. Oh, that's going to be, can I just debug this? I don't know if any can be debugged. If I run you, we found one. Right is 2. So this is okay. Query's length is 1. Okay, so we have something in there. Okay, hold on. What did we get? We got 1 any, but not 2 any's. Okay. So if I take this first one, so then there's the cast, because you're an any. You're not gonna help me at all, are you? Let's see, query 1, there's the let's see, let first component equals query 0. Okay, so that gives us this box dine any. So then I want to do first component dot let's say I even unwrap this. Oh, you don't know what that is anymore. Oh, because it's deref. Can I deref you? Okay, that gives me a dyn any. So then I want to do first component dot, okay, downcast ref into a location. So I want to let okay, so that gives me an option with this location, and then it's just unwrap, so we get a reference to the location. Now I should be able to assert equal that first location dot x. If we hi, what's wrong? What's going on? Come over here. Okay, so here's our location. So it's not that. First location of, I guess, like first location dot 0 is equal to 0 0 as opposed to 1 1. Let's see. Doesn't have a size on a compile time, so we can't do that. Size for values of type dan any cannot be known at compile time. Oh, so when I try to do the double dereference here, it didn't like that. Let's do that because I don't think it's gonna matter. Because it's still a box. I mean, what if I just do this and it doesn't matter still? It's still a box. I still should be able to do the downcast ref, should auto deref out. Strict comparison, okay. So let's fix that. So we want to do an allow compare float. Left is 1, right is 0. Okay. So this one right here found this second component here. This first one is not there. Out of curiosity, if I search for size, well, okay. So unfortunately, it doesn't look like it worked because we're not getting this one. We just got you, and that's it. I know, I'm so sorry. I love how like predictions go away. I have to choose outcome. I'm so sorry. It was a no. I wish I could give channel points, but that's not a thing that we can do. That's like controlled only by Twitch. Okay, so probably for good reasons, right? Because like then I would say like, okay, well here's another 10,000 to try again. Okay. You used to stream before and you have some bots running for friends. Oh, so you had to touch APIs and stuff? Yeah. Okay, so what happened here? Okay, let's start with so we have this here. I want to do a debug of just the entire entities. All of these entities, let's just find out what's going on. Oh right. We should probably not do this. Okay, so we have several things here. We have 2 types in a bitmap. That's correct. Okay, 1 and 2, that's correct. Our bit mask is the 3 things that we have in here. So we have entity 1 here, that we have size and location. So it is 0. It doesn't have anything. It's essentially deleted. This second thing has both of them, so it's a 3. And the third thing has one of them, so it's a 1. So these 2 are correct. But the bit mask is incorrect here. For the first one, just for the first one. So when I register entity, we bitmask push 0 in. We then do with component, get the type ID. So there's where we do, okay, so the bitmask last mute. Okay, so, okay, we do the bitmask last mute to give us the last bitmask. And then we do an or equals on it. Oh, unless that component doesn't exist. If the component doesn't exist, like we can't find the type ID of it, it's not gonna work. Basically, we come in through here and we say, okay, give us the last bit mask. Oh, you know what? So LumaCode, I think that code was right. We had a bug up here. We had a bug up here that caused it to not work. No. I bet when we fix this bug, it's gonna start working. So the problem is that it's the first entity in here, right? So it needs to register size and it needs to register location. So what happens is it comes in here and it says, hey, can I get this component? And it's no, it doesn't get it. So it comes down here, skips all of this stuff where it updates the bit mask and then adds the component in. We need to update the bitmask stuff regardless of whether or not the component is being added or not. So when we add the component, or if we get the component, we're gonna need, so we do components get, okay, so if you don't find that, then we do the last component. Because we add a new one, okay, so that makes sense. We add a new one in there. Otherwise, we add it in here, and then we do this, where we do this entire get thing. I think we can just put this out here. It's like once this is all done, then it's time for us to like grab this from you. So I think just moving out there will work. Now, okay, you have all three, you have all three, you have all three. So if we want to, so assert equal our first component I think it's going to be our query, right? So assert equal query.length is 2. That's our first test here. One passed. Okay, so it successfully found that there's 2 of these in here. So if I now debug query, it's these 2 items. Okay, that's a good sign. Now if I query for, I want to do this for a second. Let's say I query for size. I should get 3. Left is 3, right is 2. Okay, so I did. We got 3. So we're querying for location here. We get our first component. Okay, it's query 0. This is boxdine any. So if I do query 0 and then we're gonna downcast ref. It's gonna be a location. We're gonna unwrap you. We should now be able to assert that u.0 are going to be 0, 0. And then u should be 1, 0. Yeah, that's correct. We got it. Okay, so we're able to successfully query for one thing, which is good. Like this is a good sign. This is good forward progress. So like we were that close. We were that close. So I'm sorry, Luma Code. Now, let's move. I know it's like you lost fake internet points that really don't give you much. Yeah. I want to now query for 2 things. So, how would I query for 2 things? How would I query for 2 things when it's optional to be querying for 2 things? Because like, I don't know how to do that. It's like, I don't think I can have like the named query here twice, right? I don't think I can do something like pub function query, but then this is t static plus sized. Oh, wait, hold on. Plus sized. And then like S U static and sized. I don't know if I can do this. So in this case, we'd have a vec, and inside the vec we'd have a vec of a reference to box dine any. So that you get the result. Okay, so we get the result. Well, okay, so first of all, let's just return the result. Yeah, duplicate definitions with name query. So how can I have an unknown number of queries coming in? I kind of want to go do a little bit of research. So hex is a entity component system that uses that's like very, very, very simple, and I believe they have a simple query. Okay, so they have this query. Oh, they have a query. It takes in a query. So a type query, you're going to get that back. So here, we query for, we give a single type, which is a tuple. That's what that is. Okay, which is this type query? Do you have like this name somewhere? Okay, query is actually from a crate. So we can go look at that. It's a trait. Oh, and look at all of these. This is how they're doing it. This is how they handle that. I bet this is created through a macro. I can't imagine it's not, but maybe it is. Okay, let's see how they make query. Okay, so we have this trait query. Type fetch for a fetch a, so query item. Has to be unsafe. Oh, cool. I'm trying not to use unsafeness whatsoever. Okay, so they have this impl t query for that. Oh, there's so much stuff in here. But okay, I think this is what they're doing. So they're using a trait for querying, which allows them to do a type with multiple things in it. Okay, so can I like steal from that, but not go quite as far into the quite as far? So let's imagine here, okay, we have this query and it takes in this type like that. What if I have a just a trait? I'm gonna create it here. You're gonna have to be pub trait. And this is gonna be, we're gonna call this query. And we're gonna have just function query. But then you're gonna take in a tuple with type, which then implements static sized. And then you just take in a reference to self. And we're going to return a vector of what was it? It was this box dynamic. You are so upset. Bounds and associate types do not belong here. Belongs in where clause. Where do I put that? Okay, so oh, you don't even have a where here at all. So you don't go there. So function query with this type takes in self, returns this. Okay, so you are upset. Bounds associate types do not belong here. Belongs in where clause. Wait. Say. Oh, wait. I think it's here. I think it's here that I do that. So where t is static plus sized. So then query, okay. Query, okay, so is it like that? Okay. So then I just want to repeat exactly what I got now, but like down. So now we're gonna impl. Okay, so if this is struct entities. So we're gonna impl query for entities. We're gonna implement our missing members, and we're gonna take this query. I'm gonna copy you and just place you in here. And you get to be commented out. Missing generics. Okay, so this is where T comes in like that, right? Use angle brackets. Okay, so you need a T here as well. Okay, so lifetime bound. Impl T for entities. Do I do where here? So where T is static plus sized. Okay, so you're not, well, wait, you are unhappy. You're okay, fine. Okay, hold on. So you're happy down here, you're unhappy. Okay, so now we're gonna do our query. The associate function takes 0 type arguments, but 1 type argument was supplied. Wait, what? How do you not take a type argument? Type annotations needed. Cannot infer type for type parameter T. declared on the trait. Okay, so hold on. Can I update you? So you take in T like that. The name T is already used for a generic parameter in this item's generic parameters already used. So no, I can't do that there. How do I tell you to go in here and do that? Because you want me to do this up here, but I don't know how else to do that. So that's I guess I just know the T here. No, I don't know the T. So like the query needs to know what this T is. So I guess at this point in time it would need to come into here. Sort of like that. Oh, it would be like component type would be this type. I mean, so if I do this, I'm no different really. So now you're doing this as just a type and not a trait. I don't know if that helps. Helps me. Oh, because there's the different types that it could have. Like query 2, query 3, query 4. But that's not helpful. Like I'm almost thinking that the a vector of types might be more helpful, but I don't think you can pass in like a vector of types in like the type section. So I don't know how helpful this is. Okay, so how does this get used again? When we're querying, so we do world.query, and then okay, you pass in a type that you're looking for. which then, okay. I mean, it returns an iterator, which I'm not doing at this point in time yet. Okay, so that's... Oh, I think they must give you like an actual entity type. I think there's an entity. So I bet they either create this entity or store it behind the scenes, and then they can gather information from it, because then they have these things like contains and other stuff in here. Yeah, so like here's contains. Contains an entity? That's so... I'm not familiar with this functionality. But okay, so they're returning like an entity that I think that you can get stuff out of. It's like, okay, we do a query for these things. We get the entity, so we get an iterator over that. We map through it, we're gonna get the entity and then all of the components out for that. So that gives us these, okay? So then, okay, so contains entities A123.2. It's so weird, like the way that works. I don't know how much I like that. I don't know if I want like an entity, like just to get the entity back that like has stuff in it, but also like I don't know what stuff should be in there. So it feels to me like just a very simple like the database. Like here's like a vector of all the locations. Here's a vector of all the sizes. And the entities in the index lineup. And then I can just do whatever I want with those, which I mean makes sense in my mind, but like also they're doing some advanced stuff which makes it hard for me to sort of like see what what exactly they're doing. So if I wanted to query for like multiple things, they're impulling on query to get all of these. So implementations on foreign types. Oh, so then you can call query and then it does the thing according to this. So if I look at that, yeah, okay, they're using the macro to create these. It was only the first time I've seen this. Oh, it must be being run somewhere else. So if I didn't want to do this at all, and I wanted like something else, that's actually pretty, that feels like it's going to be tough unless I don't have like a query for everything together. Oh, but that's not easy. But we could do this pub trait query that takes in a T. And like, let's imagine a query type. Yeah, because I don't think this is going to work. Because this has to be like an instance of something, not just like the type itself. So that's not going to work. We already found out that we can't do the thing down here. So I don't think a trait is going to work for me. I think we're going to have to remove this and go back to what we had up here. So this works for 1. Now, let's say I wanted to do now for 2. Gonna duplicate this because I'm not really putting these into GitHub right yet. So let's see. Okay, so then I want multiple things in here, so I'm not gonna worry about the return type just yet. So I would have to do like a potential multiple things, wouldn't I? We're gonna have to have like a query builder, aren't we? That doesn't make any sense. Okay, so can I have like a struct of like a location that takes in maybe like a F32, F32. We'll have a struct size, takes in an F32. All right, I want to like to sort of recreate this and sort of like play around with what we got. So we have our struct entities. So if I try to query with like a tuple type of like, let's say A, which is static sized. Oh, would it be like A, B, which implements static sized, static sized. Let's say I don't return anything. Sized plus debug. So can I just debug A and B? So I just want to debug out what we're getting out of here. So if I do so we create a new one, and then I want to do entities.query, and I want to throw in location and size like that. Okay, so you can't do this tuple type in there, but maybe we can do like a special type up here. So if we have like type, query type, and you're gonna be like A, B. Okay, so query type AB then is going to be this AB. So then you are a query type. Okay, so we got down to here. So you should probably be that. Comparison operators cannot be chained. Oh. expected trait, found derived macro debug. Right here. Oh, not a trait. Okay, so we need to use core format debug. Oh, okay. Can I find value A in this scope? Because you don't exist. So in this case, I want to debug query type. Expected value, found type parameter, query type. I'm not sure exactly what I could do for that. So I guess I could just do a type of query type. That we'll just print that out. Isn't type ID. Type ID. That's what I want. Oops. Also, you come from standard any. The parameter type query type may not live long enough. Really? Okay. Consider an explicit lifetime bound query type static. Okay. Because we know that you are a static. So, because it implements all this stuff, so that should be fine. So, well. I got that out of it. Okay, that's great, but this is of the query type, I believe. So what if I wanted to debug query type like .0, which would be the first thing passed in? Unless I can extract this out here, where I can say like A, B. And then you become like A. Faraduda, hello. We're experimenting with we're trying to learn how to do like multiple types in one for querying in an ECS. It's not that great. Oh, Halsey's on the playground too? Oh, fun. Okay, so you don't like any of this stuff. So I can't actually do this. So even though like I have this query type here, there's no way for me to like get this out. Like, so if I put this back and we say we have query type, we know that you implement static. I want to like extract the other type out. I don't know if I can do that. Like, can't say like first type is equal to like, how do I even get this out then? Because there's no value. So unless I do something here. So we have a query is gonna be this query type, in which case this doesn't need to be generic like that. You could just say you're gonna be this query type. So now I know it's gonna be that. Then here I could do query.0. Well, that doesn't like that. I don't think I could get the type ID from it, so it'd be like query.0.type ID. Or is it type of? Might be type of. Expected 2 type arguments. Oh, for both of these, which like is not really helpful. So yeah, I don't know. I don't know how I would do this. The hex is like very, I guess like I don't know enough about generic programming in order to like understand how to do this. Like how do I build something like this out? Each one is a query. I guess that's the big thing, is like each one is a query. But if you go and look at query, oh, it's just a trait. Oh, so it's impl query. Okay, so impl query. That doesn't look like a type. That looks like it's in a type position, not a trait position. Because they're using this fetch. Let's go take a look at fetch. There is no fetch. Well then, or it's hidden and I'm not allowed to find it. That might be what it is. I think it's hidden. So if I want to query for multiple things at the same time, and I want to be able to like pass in one idea is I could just pass in the type ID straight off the bat, which is not super helpful, but maybe I can have a query builder that combines together the type IDs. That might be more helpful. I think that might be a lot more helpful. So let's imagine that I have a query builder. And let's stop this from being all broken. I know it has a derived macro for query. I mean, there's a lot of macro stuff going on with that. Let's put you all back. So you should all be happy again. So we're all happy here again. Let's now try to build ourselves a query builder. So let's imagine that we have the type IDs, right? Probably want to make this public. You're going to be a vector of type ID. For this, probably want to do like new. But we're not going to take anything in. We're going to return a new self. So that's going to be, we can just implement default on this. Okay, so we're going to start building that, right? So in here, we'd basically replace you and start saying, let our query is equal to a query builder new. Okay, so that gives us a blank query builder. Then we want to add components to it. Okay, so for component, or I guess it'd be with component, and then you're gonna have a type T, which is gonna implement static plus sized plus debug. Then self, we're gonna return ownership of self. We probably do want to return ownership of self. Let's just take in self. We're gonna return a self. And then what we do is push in the type ID that we're looking for here. So we could then say self dot type IDs dot push type ID of this is going to be RT there, like that. So then, okay, so new with component location, that. And so we have our query builder. So I should be able to debug this query so far. Although, yes, you need to have debug. Hold on. Drive debug. Drive debug. Okay, so we can see here that we have just a single type ID, but I can now query for location and size. So dot with component wait, wrong one. Query. You are going to be then dot with component size. So if I run you, we should now see 2 in there. There it goes. Okay, so now we have two things that we're querying for. So we have this query builder. So now in query, I want to run that, right? So it's like then probably like a pub function like get or run. Yeah, this would take our mute self. And this is where we would then return I want to actually just return the thing, right? So this is going to be a vec of a reference to a box with a dyn any. And then essentially we want to now call a query into the other component. So if I pass in the world, like how would I have access? I don't have access to the entities. So maybe this should be part of entities itself. Or can I just have the world be passed in? Like if I just have the world and you're a mutable just reference to the world. And I come back to here and we have this query. If I like somehow take you, put you in here, I don't need to get, yeah, okay, so there's a bunch of this stuff that we would need to like figure out. So I'm thinking that the query builder should be part of like the other thing and not its own struct. That might be what we need to do, is just do this as part of its own thing. So like instead of all this stuff in here, we'll probably need to like start query, do query, basically build a pattern inside of this component, or sorry, inside of this struct. So what if I did something like pub function new query, I don't even return anything. I don't need to, right? New query, we then have to have like a query that we're like building along the way. But I don't necessarily need to store it in here, do I? This, what if this was just a query, right? So a pub struct query, not query builder, and then you're gonna be a pub type IDs is going to be a vec of type ID, and that's it, right? So then in here, in new query, okay, so we're going to return. You don't need ownership of that. We're going to return a query. So we're just going to say query let's derive debug and default. So what if we just do query default and we return that? So then pub function query with component. Then here we add a T, which is all of this stuff. So static plus sized plus debug. No, because that just returns a query, then I'm no longer on this struct anymore. I'm now inside of query. And we could have like the self and it calls at the end for run. Can I do that? So like, let's say I just did, oh, new, because it would have to store self away and that would not work out very well. Because I don't want to give like ownership to self. Because if I did something like this, we did new self. Means we're gonna have to store like all the entities in here. So pub entities, I guess you don't need to be public. You're gonna be like a reference to entities. Well, if I'm gonna do that, you're gonna need lifetimes. Okay, so we return a new query that holds self. So that's great. Okay, so I'm able to create the new query now. So here's that. So we're gonna do a down here that yeah, basically it's gonna be letter results. So results, it's gonna be equal to entities.query. Oh, it's new query. Okay, so that gives us this query, but it includes the thing that we want to include, maybe. So that's great. We have that. Now we want to like, with component, but that's not going to be on here. That's now going to be on here. So with component, we'll have a type, which is static sized debug. Actually, we're taking ownership of this. This is a mute self. And we're going to return a self, yes. And so we're going to self type close. Then we're going to have type ID of T. Okay, we do that. And then we return self. This allows me to come back into here and okay, so new query, then dot with component location. So this gives me that, and then I want to essentially run the query. So in here, we're going to have, I'm going to rename you to run query. You don't take this. You're going to take a query in. Don't know if I can give ownership of this, but maybe I can. And then you're going to return this all the way back. So I don't need the type ID because we have that already. Okay, so I'm just going to ignore all of you except that first and last line. Yes, taken a self. And we're going to return this thing. We're going to do self dot run. Sorry, self dot entities. Run query and pass in self. And then return what it returns. Okay, you're not hating this to the nth degree. There is that. Okay. So then run query does its thing. It's gonna return this stuff. So if we run this now, we'll see just an empty array. Wait, do I have multiple debugs? Result equals query. Oh, it's this entire query. Wait a second. Oh, wait, because I didn't do run. So dot run. There we go. That should give us what we want. Now it's an empty. Okay, so it's this empty vector. So now to actually do the thing, to do the query, we're getting the query in, and the query has a vector of the type IDs. So for each, we need to loop through those type IDs. So we're going to do for type ID in query.type IDs. Hello. Zobi. Hey, Zobi. Hi. Want to come over here? No? Okay. Okay, so we have our type IDs. We need to get the appropriate, like, we don't even know which one it is, and I don't know if that even matters. So for each of these type IDs, we're going to, well, it kind of does matter, doesn't it? Well, it's the order that it's been requested in. It's the order that's been requested in. So if I'm requesting location, and I could also do with component size. So I can request both of these. So give me something with both location and size. But we know that location is first. So I need to get the location bitmap. Hi. I need to get the location bitmap. And then we can loop through all of the locations to get all the locations, and then test to see if you have those, and then add them into the results. What are you doing? Did you have fun? I'll give you a treat if you okay, hold on. Nope, stop. Probably shouldn't have done this right on the keyboard. Hey, you're not allowed to steal all these. Over here, come here. Good boy. Super low calorie snack, which is good because he's helping. I know he's doing something. He's deleting all the code. Oh, wonderful. Okay, how about this? Sylvie? Oh, that's my bug. You probably don't want to look at Sylvie, come over here. Sylvie, come here. Sylvie, come here. Good boy. You can have that. Hey, Australia, come here. Good boy. Got one more. Sylvie, come here. Come here. Good boy. That's it. Okay, let's all right, I think we're good now. Yeah, we're in an unsaved position unless he's been saving it too. Who knows? That's it. Yes. You know what's going to be great is if Copilot learns from Zilby and then people just get random crap in their code because there's now a cat AI programming. I kind of want that to happen. Okay, so we have all these type IDs. Now we're taking ownership of this, so we could probably just do an iter. I don't really need ownership of it at all. Bear, you found some kitties? Oh my gosh. There are some kitties doing hacksers. They're hacking. Thank you, Bear. That is super cute. Okay, so I got that. Where's the type IDs? Come on, you have that in here. Query.type IDs. Why don't you think you have that? Oh, you do think that. I just need to save for it to see that. Okay, so we have 4 type ID in this. If we have this type ID, we can now get the bit mask and we can get the. So I guess let's start with finding the entity. So it doesn't really matter, does it? We can get. We have another row. Okay, so we have another row here. So let mute. This is going to be the entity results. Okay, it's empty vector. Then I want to get the bitmap. So that bitmap. Okay, so we're gonna get that out. Now, if this is an unwrap, that's gonna crash. So like, for example, if I request something that doesn't have it. So I kind of want this to be an if let sum. Right. So the bitmap equals let sum map equals to you. Okay, so we're gonna just return bitmap. Otherwise, we're gonna do an early return. a result. You know, I kind of want to just make this a vector here. So, sorry, we're gonna do a result. Put this inside. You're an error result, so we're gonna return. We're gonna bail. And our bail is gonna be type ID not found, or type not found. Component of type not found. Okay. So now I have the bitmap here. I can actually dereference at that point because we might as well just take this. We need the dereference stuff anyways. Okay. So now, we have our bitmap. Now the bitmap is for this specific type, so that's fine. We also need all the entities for this type. So if we get to this point, we should be able to find the entities, but we can still fail if if we don't find it for some reason. So maybe let's just be more bitmap for query type not found. So let's do let components equals let some self.components. I don't need to get mute. Okay, we're gonna do type ID. In this case, I do only want a reference to there, so that's gonna be fine. Else, we're gonna bail components for query type not found. That's fine. Okay, so I have our bitmap. We have the list of components. Now we can loop through the components. We're gonna loop through the okay, so we're gonna loop through the components. And then for each of these components, is that true? For each of these components, so really the big thing is like we have our user and we need to know for like location and size, for example, if your bit mask for both bitmaps, for all the bitmaps, if that's true, then we want that. Oh, so maybe this is, I mean, I'm almost guaranteed to be over complexifying it. I don't think that's a word, but it's an overly complex way to say complex, so that feels right. Okay, so what I really want to do is like for the bitmap of each of these things, I need to know like, are you going to be getting this thing? And if you are, then let's like grab it. So we're getting this bitmap here. But that's the bitmap. That's the bitmap for this type. So I almost want to do something like, should the player be getting? Like almost like a let. Do I want something out here? Like let so we have the results for the bitmap. Let's say, okay, the first time through, this is location. So do we have the location? We just have the bitmap of location. I need to now get my bitmap, the player bitmap. So I need to enumerate in this. So the index and the type ID. Okay, so hold on. I don't know if we need this. We have the bitmap here. From this bitmap, I now need to know, am I allowed to take, like, to get this? Does the player have access to this? So I guess what I really need to do is get the IDs, get the indexes where the player has access to both. So this would be something like let mute players, or I guess like it's not going to be like the entity indexes. Is going to be this empty vector. Then in here, we're going to say, okay, okay, so for this query, I want to see if the player has both. If the player has this, then we're good to go. But it needs both of them, right? So we need to wait until the end of the loop to know for certain. We need to try twice. We could run a method on query. We could abstract this into query. That might make it a little bit that might help out a little bit. So we need to say, okay, so for each, we need to loop through this bit mask. We need to loop through the bit mask and then say, hey, for this bit mask, are you in both of these? If you are, then we're good to go. Almost like I need a copy of bitmask, but with just true or false in each of the locations. It's not necessarily what I really want to do. as I'm building it, when I do run, at that point in time, we can find out, right? So we could then get the indexes what we're looking for. It's like, what if in this point we have this run and we have access to entities, which means we have access to the bit mask and we have access to the bit map. We can then loop through each bit mask and find out, like, do you, I guess this would be like contains, or like has all, or something like that. Has all might be good. So I could actually run off of entities. I can run a method like has all. And then we could have, okay, so we have the type IDs here. What if we also have like a pub, this is like the index, the query indexes. So the indexes is just going to be a vec of usize. So you start with nothing because nobody had, like, this query doesn't, we're not going to be pulling anything out. When we hit run, we need to get, for the entities, we need to get a list of the bit mask. And then for each bit mask in here, we need to check against each of the each of the bit map items based upon the type IDs. So what if I just wrote like a has a? I guess I don't know exactly where this would go. It's like we have this in run. Would I want to put this in here where I grab the bit? It would be for each player, right? So if I do like for entity bit mask in self dot, and no, not all those, self dot entities dot bit mask. I mean, I guess we could just take ownership of it because it's just going to clone or copy in this case. So we have you. Oh, the vector. Okay. So fine. We'll just do iter. I'll just dereference it when I need to. Okay, so we have this U128. That's our bit mask. So we want to see like, okay, are you in any of these type IDs? Now I don't have like the type IDs there. So instead I need to get so like if I have like, does player have this type ID? Like if I does player have this component? And if I hand it a type ID and a U128, a bit mask, it's going to tell me. So, so entity contains. So what we're going to care about here is we need a type ID. And then we need the map. So the bit map is going to be a, yeah, probably just U128, and we're going to return a Boolean. So to begin with, we're going to extract out. So if let some, this is not going to be a full component. This is going to be the bit mask. Self dot bitmap and mask actually. So your bit, the map, self dot bit map dot get this type ID. Okay, so we have that. Now I want, no, I don't want to do that. I want to do bit mask and this is going to be the bit map. So bit mask is that, and that is equal to the bit map. So that's what we're going to return. Else, we're going to return false. So now we can do this entity contains here. So if the entity contains this, okay, so then we have, oh, we need, okay, so we need to loop through all the type IDs too. Okay, so if self.entities.entity contains a reference to the type ID and a dereferenced bit mask, then we know we have this, so the index that we care about in this case we're going to push in the indexes that we want here. So you're going to be enumerate. So we can index here. I'm going to do self dot indexes that push index. Hi, Zilby. Zilby. Hi. Oh, I have the cat. Sorry about that. It's good. All right. Does that make sense? Can you see? There you go. You can see they'll be hanging out there. Okay, so then okay. And then, okay, so we're adding all the indexes that we're caring about, and then we go to run query. So in run query now, let's just reset this again. Let's just like not even pretend that we're going to return anything. Let's just debug. It's going to be the query dot indexes. That's all I really care about at this time. So what we're going to do is entities, new query with these components, and then run. And there's not even a results for us to look at. Self.entities, what is it? Line 37. And query builders. Oh, right. You're not returning anything there. Okay. Oh, and we're not returning you. Okay, so you got 001122. So you have, we're looking for both locations and size. So position 0 has, so index 0 has a location and a size. 1 has location and size. 2 only has a size. So we're looking for both, right? So in here, we don't want to push this in unless it's true for both of these, right? So has this, okay, let mute as component equals true. Then we loop through all of these. If this is not true, then we want to set the flag to false. So as component equals false, and then we can break out of this loop here. So component doesn't have that. At the end of this one, if has component, then we want to push this index in. So position 0 and 1 are the only ones that have both a location and a size. If, however, we're searching for just size, we should get all three. And this should be the same if we're only looking for size. If we're only looking for location, we should get 1 and 2, but that's the same thing. So I think this is working. I think we're doing good here. Okay, so then with the run, we should now expect us to get the actual thing back. So in entities, so we now have these indexes, which I think is going to make this a little bit simpler. So run query. We need to loop through the indexes. And that's true. We need to get a list of all the components. I wonder if I can do a map for this. It might be too much. Basically, because we have a list of type IDs that we're going for. So this is just the indexes of the components. So we need to loop through the type IDs and get the components for them, and then loop through the indexes and pull out those ones. Probably loop through the components first, or sorry, loop through the indexes first. So like for index and query dot indexes. Then we also need to get the type IDs. So this is gonna be 2 for loops again, right? So for type ID, this can be a let's see, type ID in self dot type IDs dot iter. No, not self. Query dot type IDs dot iter. Okay, I think we have everything we need now. So we're going to let our components equals, I guess this will be an if let. If let some components this is going to be our type ID. Okay, so if we found it, then we want to pull the index in. This is going to do a lot of gets into it. I don't know if that's what we want to do. I think we want to do the opposite, right? We want to do it per component. So do this. Well, okay. So first of all, I know like I'm going back and forth on this, but like we're gonna get there. We're gonna get there. First of all, if that's an empty vector, we're done. You support me mentally? Well, thank you. So let's do that. We're gonna return a result. So we're gonna have a result of something. Which is gonna be a vector of, well, if I remember correctly, it was that reference to the box. Well, it's actually gonna be multiple. We're gonna have two vectors, but then we're gonna have the box with the dine. So we're gonna start with this. And then what I think we need to do is we're gonna get the components that we're looking for, and then for each of them, then we can do the other stuff. So we're gonna loop through the type IDs. So let for type ID in query dot type IDs, iter through that. Okay, so then we have this type ID. Then we're gonna get the components. Pass the type ID. And that gets us now a vec of these, okay? So then we want to see if this is in the index. So if I do this, if I iterate through these components, but I enumerate, which is going to give me an index here, I can do an index. Because we have the indexes. So is there like a contains? So can I do like a query dot indexes dot contains this index? Okay, so wait a second, the index is just true or false, right? No, okay. It is the actual indexes. Okay, so if I do this, contains that. So if you contain that, then we want to push in for this component. So a brand new vector here, and you're going to get pushed in here. So create components, push this component. But we need to, so you're this option. So we need to dot as ref. They're going to unwrap, which should give us the reference to the box identity. And at the end of this here, we're then going to do result.push create components. So then we're going to take you. That is what you're returning. Okay. So then if I come down here, I'm not even like assigning it to anything. So let create equals. So we have this here. Let's just try debugging the query. I think it worked. So, can I deal with this? Can I deal with our any to like turn it into whatever it's supposed to be? Oh, but I don't know if the type anymore has been lost. Okay, so I don't know if I can right now. So we have this query which is vec box of dyn any. So if I debug query of position 0, so that's locations of position 0, which should be this first location, this one right here. Types, who needs types? I do. Then I want to downcast ref as a location. Okay. That's the first one. That is the first one. So if we do the second one, we should get that 1, 1. And there it is. Okay. So this is what our queries would be now. We query, we do the new query with components, we run, and then our query is this like vector of things. It's like not beautiful, but allows us to now have as many like as many components as I want to query for as I need to. That's great, but now I have to do this downcast ref for location, which kind of sucks. So is there a way for me to remember the type so I can downcast it inside of each of these? Now, is there a way for me to get the type back from the type ID? I don't see one. Like a bunch of like intos. How about for any? type name. So wait a second, what's this type name? Okay, so you don't, that's not something, this says it's on any, but maybe it's not really? And then it's hard for me to, can I do something, can I do something crazy? Can I say like, I want you to be a vec with a vec of location and a vec of size like that? Okay, so can I do that? I know, you're not it. Don't worry. And then in here, oh, because I can't do it here. I'd have to do it in the, at this point. So if I want to say like you're dying, that you're just T. Like, heck, like you're just a reference to T. Then so you're fine at that point. Well, okay, you're not fine. Because we don't know what that is. It would be like TNA, we're back to the same problem again. So this might be the best I can do without being like really, really evil. Unless like I do another thing here or somehow store away the types, which I don't think I can do. I think I would need like a ton of macros to be able to like, okay, this is like the location and we're like creating that, but I don't know if that's gonna be helpful. Yeah, so do this any. And here we're just any. So we can get the type ID. Return true if it's that type. Wait a second. So we could get the type ID off of here. Like dot type ID. So that works. Yeah, so we can see like, okay, it's that type ID. I could like maybe figure out that that was the type ID of the first thing passed in, which is great. I don't know if that actually helps me. There's also type. This claims there's type name. But it claims there's not. So the dot should bring it past the box and go to any. Oh, it's a different type ID. So this is the actual type ID of the thing. The other one, I think I got the type ID of the box, which is not what I wanted. So this time, can I do type name? No, okay, so die in any, unless I need to do like another deref. Yeah, like a die in any doesn't have that. Oh, is it because it's a die in any and not an any? It's just something, it's just based on the trait. Okay, so wait a second. This is this a trait or is this a, but okay, it is a trait. So there's only function type any. Why is it showing me type name? Oh, that's under the any. Okay, that's under here. There's several functions. Oh, type name and then pass it a type. And it gives you the name. Okay. I guess that makes sense, but like, I don't know if that really helps me in any way. So I think we've reached the limit of like how nice I can be to myself when building this, because we're gonna have to downcast once we get out of it. I'm don't think I can downcast inside the query because I started the query here. But it's actually doing the work here. Which means there's no way for me to know what this is to downcast it anymore. So that's it. Like we're good there. We're just gonna have to downcast here. So if I want to say, okay, so don't need to do that. So we're gonna say, okay, so query is this vec of x, so the query dot length should be 2. So we queried for 2 components, that's fine. We also want to assert equal that query of 0 dot length is 2, so we only got 2 components. So the first component, the first set of components and the first entity's component, we downcast ref to location, we unwrap that, and we get the first item, and that should be 0, 0, and we do the same thing. But for the first item, and that should be that. We can do this exact same thing again. But this is going to be 1 and 1. And so you're going to be size. And your sizes are 10 and 11. So your dot 0. You're 10 and you're 11. Yeah, all of that passed. We're getting that out. Okay. Oh man. Now, what's nice is this query is pretty clean. Like this is the worst part here, this downcast. But it's not the absolute worst thing in the world. It's actually like this entire thing, creating 3 entities and querying for them all fits on one screen, which is way better than we had with the original baby ECS. Our query builder is a little bit interesting because we have to have a couple different things like going back and forth in order to like store the type IDs and get that going. I don't think I can actually just store types. A series like a vec. I think the only way we can improve this further is then going into the realm of macros, which a macro could allow us to hide this downcast. The macro would hide the downcast. Absolutely. And give us what we want. I don't know how I would want to do this as part of this tutorial, but maybe we do. Now, let's say I wanted to do this entire thing, but get it mutably. So I want to do this again. So test querying for mutable or test mutably. Then mute, we create the 3 entities. That's going to be fine. I want to, let's see about this. I want a mute at this one. So new mute query with component, and then we want to like basically do some updates to it. So I want a mute query. The with component should be the same. Actually, the new query should probably be the same here too. Really what's going to be different is we want like run mute is going to be the new thing. So we're gonna have hub function run mute. And it's gonna be this entire thing with one tiny difference is you're gonna be a mutable reference. Is that how it works? Yeah, okay, that's how it works. So then we're gonna do similar things here. But we're gonna run a mute query is the big difference. So this could probably be combined together. But okay, so now we're gonna have a run mute query. So run query. It's now gonna be run mute query. It's gonna be a mutable reference to self. We're still gonna take ownership of the query. And then the big things is okay for type IDs. I don't care about that. Queried components, components. So you need to be get mute. You're gonna be a mute box. Okay, you're that there. So then you need to be iter mute. As mute ref, I think. Right, cannot borrow it twice. Okay, self.components. Oh, previous iteration of the loop. Oh, because self.components, which is a hash map of all the components. Do I have to like drop it multiple times? I don't think I have to drop like components multiple times. No. I don't think I can do like drop self.components and then we pick it up again. No, because like that's not how it works. So self.components get mute. So we get that mutably. So this is where the interior. So, okay. We run into this problem. This is going to take a lot to fix. The easiest way for us to handle this is to not have a mutable version. We only have immutable queries. It's like, great, okay, that's fine. The problem is, instead of this box, we should probably now have like you can now just be an RC. Then inside of here, we're gonna have to have a ref cell, then a dyn any. Okay, you're then in here. Okay, so option. So inside this box, I have an RC, and then a ref cell. Okay, some RC new, ref cell new. Then here, okay, so add components. Okay, so push. Okay, so we need to tell you what you're gonna be. It's gonna be RC, cell, RC new, cell new. Okay, so for run query, RC. Okay, so then here, what's going to be great about this, we have our component here. We should be able to just unwrap this option. We're going to push in this component. So you are currently this option RC. So what I want to do is dot as ref that turns into that. We unwrap you, and then I clone you. And that clones the RC. RCs are smart pointers, so they can be cloned, but it's still the original data, which is awesome. Okay, then down here, now we don't have a run mute, so we don't even need this test. Okay, up to you, and then you are going to be what we're returning. So we're now returning, we're owning this now. So it's now an RC with a ref cell. Okay. Then down to here. So there's this no, the downcast ref, we can't do that right away, right? So like this gives us the RC ref cell, so we need to borrow this first. Okay. And then we can do that. Or we can borrow mute for internal mutability, but we don't need to test for that because that's what smart pointers do. So then everything should still work. Yep. It's a little ugly, but it works. And it gives us interior mutability. So like perhaps a macro could help with this a lot. The macro would probably be just for the query, and then we leave the centralized code, like the main code, all on its own. So if we take a look at what this query is, if I want to then turn this into like actually like the downcast things, could I do that? I don't know. I might wait until later to like even decide to do that. This isn't like too terrible of a sort of like a system to have. But okay, so this gives us we actually need, we can go back into zombies. It's been a while since we've been in here. Right, the entire point of this was we wanted to create some entities to store into here. So for example, we're going to want an entity, probably like a human. So let's create a new folder called entities. No, these are not entities. These are components. Okay, so then here we're gonna have probably like a human component. Actually, no. We don't. The entity is gonna be human. What does a human have? What do we need to like display a human out onto the screen? We're gonna need the player. Okay, so we need a location. We already have a mesh. I guess right now we could just use a location. So we're gonna call this location. Let's create that. So location is going to be a tuple type. You're going to hold a, I mean, it could be a vector too, but it could just be like a mint too also. We could also just do like this. F32, F32. I think this will be fine. Like we can also impl dref for location, and in this specific, I don't know if we need anything special with it. There's all this data structure. We can use the vector 2 in here, which actually might be good. Let's do that. You're gonna be this vector 2. So then we're gonna head back to our main library. Okay, so we get, here's our world, we add these resources. All right, let's add in an entity. So we're gonna do world. Oh, wait, did I didn't do it. We have the entities here for like add entity on that stuff. Let's see. Register entity, it returns that, and then with component. Okay. So then in our main library, we just need hub function register entity. You don't need anything, but you're gonna return a mute self. So you're going to return a mutable reference. Is it a mutable reference? Yeah, mutable reference to an entity. Entities. Okay, so that just that forwards that on, but I think we're good now. So back into here. Okay, so we're gonna do world dot register entity, and then we can do with component. So our component is going to be this location that has this vector2. So we're going to need vector2 sure, well, sort of. And that's it. That's all we need to do here. There's no like build. We've just done that. Okay, so we have that. Now we need our first system to actually display this to the screen. Okay, so for our systems, what's our first system going to be? Probably like just display. So like draw entities. So draw entity is probably going to be an empty struct like this. And then we're going to just import off of draw entities. Let's just have a run. I mean, we could just take ownership. It doesn't matter. I think we're done with it after this. Then we're going to take in, okay, so we need a context. Okay, so we need the world. We need the world, which is going to be a reference to the world. We do not need ownership of this. That's going to be fine. We need a context. And we're going to return a result with nothing in it. Okay, so we need to first get out to extract out the hash, then the mesh. So that it's like the mesh is going to be equal to world dot get resource. How do you work? Oh, get resource in this T. So our resource we have this entity. Oh, entity mesh doesn't have anything in it. Wait, what was I putting in here? Got all that stuff in. Hold on. Oh, so far all we've done is we've okay. We've added a resource for the arena size and the background color. That's it. Oh, that's cool. Not that great. Okay, so we need okay, so we have this. We have actual mesh. So we should be able to add a resource for the mesh. So add resource. We should be able to pull in a mesh. So here, object mesh. Submod mesh. We don't need that anymore. Okay. Import this mesh. So new radius and context. Okay. We have the context. Okay, so mesh. New. Radius, let's do like 50.0, and then we'll pass in the context. And okay, we're returning a result. So then here, question mark that. And there we go. Okay, so now we have this resource added in. Nice. Great. So then back to draw entities. We need to get this out. So this is a mesh. We should be able to unwrap that. So that should give us that. Okay. So now we have a reference to our mesh. Now we need to do our query. So query for locations. So query is going to be equal to world dot. Oh, kind of need to like do the query forwarding thing through too. So inside of new query. Okay. So this is going to be a query builder. Is that right? Full ownership of a query. Query. So we're going to do self.entities dot new query. So, okay, so query with component. In this case, I want a location, and that's it. And then we're just gonna run. That gives us this vec of a vec. We are only searching for one thing, so I don't need to worry about anything more than just like the first item. But we'll get to that. So I guess we're just gonna do for location in query dot first. Okay. That's going to give us just this first one. Okay, that gives us, okay, this RC. We need to now extract this out, right? So the RC we can get in directly, but then the ref cell, we need to borrow it. So we're going to do that patient equals patient dot borrow. Okay, so we have this now a ref dyn any, and then can I just downcast ref to a patient, and we're gonna unwrap you. Okay, we have a reference to our location now. So then I want to actually do our draw. So we're going to do a graphics draw, and at the context, hand it the drawable, which in this case is the mesh, and then we're gonna do some draw params. And we have to send it to the destination of this location. So now if I want to do some, I want to deref out into like the actual thing. So I want to impl deref for location. Okay, so type target is going to equal the vector 2. And we're going to do self dot 0. Is that right? Okay, fine. You're a reference there. Oh, function deref that. A reference to self.0. Okay, that's cool. And then if I want to go to vector 2 and I want to add a new function in here, so pub function. Let's do like 2 mint 2. Actually, wait, no, I can do an into. I can do an into. Then I think this will work just magically. Impl into for a mint 2. I think it's actually a vector 2 f32 for vector 2. Okay. Oh, this takes ownership. What's the one? Oh, I don't want to take ownership. Yeah, okay. I don't want to do that. So pub function, we'll probably just want to go like not into, maybe 2. 2 mint 2 mint vector 2. Taking reference self, mint vector 2, 32. Then we're gonna do, okay, mint vector 2, self.x, self.y. Oh, but you don't have that. Hold on. Then it's there it is. Like that. Type argument. Oh, wait. Don't do that. Don't do that. Do something like that. Okay, so then we have this 2 mint to that. So now we can come back to here. I'm gonna do location dot 2 mint vector 2. That should make you happy. We're going to question mark you. Mesh. This is essentially mesh dot 0. Is that right? your private okay. Now you're upset. Component. Oh, location doesn't implement debug. We can fix that. Derive debug. Okay, so location borrow. Oh, temporary. Okay, so I can't do this all together in one spot. You have to do like borrowed location equals this, and then let location equals the borrowed location dot now we can downcast. Like that. Okay, no errors. Let's see if we can call and like run this. So we have draw entities. Let's head back to the main library. We're gonna have up here, okay, in draw. So after we clear the screen, we're gonna want to get, what is it called? It's, so let draw entities. Draw entities like that, and then draw entities. I think it's like backwards. Oh, dot run. Then we have the world, so reference to self dot world and the context. Okay, no errors. Oh, unwrapped on a none value. In draw entities. Okay, so line 14. Okay, so right here, there was... Oh, get the mesh. Okay, so that failed. Do we not have them? I thought we inserted the mesh. Okay, so here, add resource, mesh, new. The mesh is from mesh, okay. Resources mesh, from... Wait, where are you from? Oh, resources, okay, mesh. Okay, that is correct. Are you not... Can I like debug the world? Okay, so resources, here's the types ID and we have like the data. Okay. I may have to get that. Let's see, and then what's the type ID of this? So if I do type ID, come on. Okay, so here's our type ID. It's a 178 and then 558. Well, okay, that's a problem right away. There is no type ID 178. Well, that's why I can't find it. It's not in here. Well. When I'm adding a resource, okay, so add resource, background color, arena size, mesh new. Okay, so you're you're turning this result RC ref cell self. Oh, I think we have an old mesh system here. We don't need to do this. We just need to return a result with the mesh inside. So we create the mesh, we build that, and then we just do return OK and the mesh. And I think that should be okay. Why are you upset? Expected resources mesh found. Oh, you need to be a. Oh, you're right. Okay, wait. Ote self mesh like that. There we go. There we go, and we have our human in the top left. We're able to successfully extract them out and do a query for our human, which is in the top left corner of the screen. It's a really large human. It doesn't do anything interesting yet, but this is the first part of this, is that we're now able to create systems that query for get this stuff, and then we'll also be able to create systems to mutate these and like have them move around. So that'll be interesting and good too. All right, so I'm super happy with this. It's set ourselves up for success with everything else. Let's go ahead and find or draw entities. Let's remove this debug. We don't need that anymore. We can in here now tell your location. First of all, our radius, let's make this more reasonable, like 15. Let's make this like 100 to the right and maybe like 100 down. If I run this, it'll just sort of be in there. And there we go. We might even want to make that a little bit smaller. And then it's like, what's coming up? Now it's starting to use it, right? Like maybe now it's going to be logic inside of the zombie simulator, where we're going to have to create a whole bunch of humans and have them move around and avoid each other, and then introduce zombies when we click and all that fun stuff. That's probably what we're going to be starting on tomorrow morning, because I'm starting to feel a little bit low energy, and I'm going to have to go basically go fix that. Probably go eat something and take a break, walk around a little bit. I've been sitting down for a very long time. So let's go ahead and bring everything